2, 1, here we go. So I have a graph right in front of you here on your notes of it's a rotated ellipse, right? An ellipse is basically a flattened circle. It has 2 different radii. And instead of a center, then it has what's called foci, right? So if you take the center, 1 point, and you move it left and right, in this case, you'll have and this is not part of the problem, but you have a focus over here and a focus over there, okay? And then there's a radius called the major axis and the minor axis, okay? How far it is from here to here, and then how far it is from here to here. But this one's rotated. What we want to do is figure out where the horizontal tangents are. So notice there is a horizontal tangent over here, and there's another horizontal tangent over here. So again, it looks like they're going to be symmetrical because this thing is symmetrical rotationally. So it might be like negative something, negative something, positive something, and positive something, negative something. All right. So how are we going to figure out where it has horizontal tangents? Well, what's the value of the derivative there? What is the value of dy dx? 0, right? So that's our plan of action. I need to find the derivative of y with respect to x, set it equal to 0, and solve, right? Okay, got it. So here's the equation of the rotated ellipse. It's not solved for y, and I'm not going to solve it for y. Did she get it to work? She got it to work. All right. So here we go. Let's take the derivative. d dx the verb colon. d dx the verb colon. 1, 2, 3, 4. There's 4 terms. How many y's do we have there? 2, right? So we should have 2 dy dx's in our answer. Success on the calculator? Yes, nice. Unicorns helping unicorns. All right, so 2x squared becomes 4x to the first times the chain rule, dx, right? Which we don't need. Plus, now here's where you got to be careful. This is a product rule, isn't it? It's x times y. So that's going to generate 2 terms. So the derivative of x is 1 times y goes along for the ride, plus x goes along for the ride times the derivative of y, which is dy dx. So this thing generates these 2 terms. You would need to be extra careful if that had been a minus sign there. I have seen students, if this were a minus sign, forget to distribute it. In that case, it's probably easier just to have both terms as negative, okay? Think of the first factor, in other words, as negative x, but not in this case, all right? And then we get plus 4y squared's derivative, which is 8y to the first times the chain rule, dy dx. And then something I pretty much do all the time, I forget to take the derivative of the right. I write 3 down instead of 0. Run through the tape at the end of the race. Yeah, that way you get the finishing shirt. Okay, so there it is. Now, if I was just looking for a specific derivative at a specific point, I would plug in and then solve. But I need to solve for dy dx. So I need to get the 2 terms now that have dy dx expanded and on the same side. Well, they're already on the same side, yes? So I can factor it out. And that leaves me an x plus 8y. And then whatever is not highlighted, which is just that first term, which is positive y, comes across and becomes negative y. All right. And then there's also a what? Negative 4x. Yeah, don't forget about that. I almost did. Negative 4x. So this term and this term go to the other side. And now I divide through, and you get dy dx equals, I'm going to put the x first. Negative 4x minus y all over x plus 8y. Now, I do want to set that 0, but I also want to point something out to you. Let's say this was a multiple choice question, and it said which of the following is dy dx. That might not be an answer choice. So let's just look at other versions of this, okay? If you factored out the negative from both terms in the numerator, you could factor it out and put it out front. And that would make that a positive 4x and a positive y all over an x plus 8y, okay? If you factor it out of the top, you can put it out front. And when you put it out front, it's usually on the same level as the division bar, okay? That's probably the preferred way to package the answer because it emphasizes the positivity, right? All the terms are positive. So just be mindful of that. Another thing that could happen is if you collected your dy dx's on the opposite side of the equation, you can imagine just multiplying by -1 over -1 and distributing. Okay, what that does is it changes the signs. That becomes positive 4x positive y over -x minus 8y. Okay, it would also be the same as like factoring the negative out of the top and then redistributing it in the bottom. You can get there that way as well. But -1 over -1 distribute. So a couple of different versions of the exact same thing. All right. Now, for our purpose, it doesn't really matter which one we use. I think I'm going to stick with this one here. That negative out front, to me, it's a liability. I don't really like it out there. Okay, so I'm going to use the original one we had. I want to find the horizontal tangent. So I'm going to come over here now where there's room, and I need to show what I'm doing. So dy dx equals 0. That would earn a check. All right, now watch this. We have a fraction. I want to know when the fraction is equal to 0. That's going to be exclusively when the what 0, top or bottom? Top. Okay, good. So we set the top equal to 0 underneath there. Now I have negative 4x minus y. So I'm going to take the negative with it. Negative 4x minus y equals 0. Now here's the problem. I can't really solve that for a single value. There's two equations with one unknown. So golly, what do? How do I solve that? Well, here's the deal. I need to solve a system of equations. The values that I'm finding that are going to make this true also are going to make the original equation true. They're going to live on the original graph. So here's what you do. And this is a pretty typical thing. You solve for the easier variable. Solve for the easier variable. Which one is that? The x or the y? Y, okay? So I get y equals negative 4x. And now you're going to plug into the original equation. Okay, at this point, if we had like y equals a number, we would be done. And just to review what we did at the end of last week, we actually did that. We had a number and we were able to plug it in. But in this case, we have a variable. Okay, so I got y equals 4x. So let's come up to the original equation. I'm going to copy it. Oops. It automatically copies. Okay. Paste it here. And now I'm going to say at, or how about, yeah, at y equals negative 4x, or something to that effect, when y equals negative 4x, just to show that we're plugging in. We're going to get 2x squared plus x times y plus 4y squared equals 3. And what are we going to plug in here where y used to be? A negative 4x. From this equation here, I set the numerator equal to 0, and then I just solved that for y. I just took this negative y to the other side and then flipped it around. Yeah. This is about the most algebra that we're going to be doing all year long. Just an FYI. It's very, very tedious. Okay. I don't think the idea is difficult, but it's very, very tedious. Now, when you solve for the easier of the two variables, College Board and I will have the problem set up so that at this point, the algebra will work out because it's going to be a non-calculator question. So just have faith in the work. Okay. So we get minus 4x squared on that one. We get minus 16. I'm sorry, you got to be careful, right? This one is squared. We got to square the inside first, right? Negative 4x times negative 4x is actually positive 16x squared. And then that 16 gets multiplied by the 4, doesn't it? So it's positive 64x squared. Yeah. Now notice we do have like terms at this point, right? That's what I mean by it's going to work out. You just got to have the right coefficients. So careful. All right, so 64 minus 4 is 60. We get 2 added back, so we get 62x squared equals 3. We divide through by 62 and we get 3 60-seconds. And then how do we solve for x? Plus or minus the square root of 3 over 62. Okay. Now, look at what the question actually asked us. It said to find the x values of the horizontal tangent. Did we just do that? Yes. Okay. So when you solve for the easier of the two variables, you're going to be solving for the variable that College Board is essentially asking you to. Okay. But here's the deal. If it did ask for the y values, all you'd have to do is plug these in individually one at a time to either the original equation, yucky, yucky, gross, gross, or this equation here. It's kind of like when we have systems of equations. Let's go ahead and do that because we didn't get to do that on Friday. We got caught by the bell. So if we use this equation, y equals negative 4x, then I could say, let's use function notation. Y of positive square root of 3/62 is going to be negative 4 times the square root of 3/62. And then y of negative square root of 3/62, what a fantastic number, is going to be negative 4 times negative. That's positive 4 times 3/62. So that's the easiest way to find the y values. So now, if we really wanted to, we can find the actual points, right? In function notation, they're really written right there. It'll be positive square root of 3/62, negative 4 square root of 3/62. That's going to be the one that's in quadrant 4, and negative square root of 3/62, comma, negative 4, positive 4 square root of 3/62. That's the one that's in quadrant 1. Those are ugly, right? They're ugly. So typically, you're not going to have to find the other variable. If you read carefully, it says to find the x value. So we would stop right here with all the work shown. And you could list them as plus or minus. Now, if it did ask for the points, let's say it was like an easier looking number, could we just combine these 2 points and say plus or minus square root of 3/62, comma, plus or minus? We can't do that because that would give you 4 points, right? You wouldn't know how to pair them up, right? So this is important because this puts them in opposite quadrants, quadrant 4 and quadrant 2. And the plus or minus would then imply that they're also in opposite quadrants 1 and 3, and they're not. Okay. All right. A lot of algebra, right? A lot of algebra. Here's what I want you to do. Kind of a similar idea now. Determine the y values for the vertical tangents. You are going to have 2 of them. You can actually see on the graph, you're going to have one there and one there. They should be symmetrical again. But use part A as a guide and go ahead and do part B on your own. All right, so here, let's free response. Here's what you would show. You always have to show the equation you're solving. So I'm just writing this out. This is kind of me thinking, but it's also part of the justifying. We get vertical tangents when we have a derivative, bless you, that's some type of infinity, plus or minus infinity. You can't ski down it, right? It's called free falling, infinite slope, or DNE. So we set the denominator equal to 0. So that's what's going to get the check, right? When you put dy dx equals DNE, that's fantastic. That indicates your method, but then it comes down to setting the denominator equal to 0. It's a lot easier to solve for x than it is for y, so I'll solve for x and you get negative 8y. This is the key right here. That's the relation between x and y that needs to be maintained to get vertical tangents. So now you take the original equation that was given and you plug that in. So when x equals negative 8y, you must have had some takers. Yeah, nice. You plug it in, so you get 2 times. And here's where the algebra gets kind of, ugly. X and x, but those both become negative 8y. Plug it in. They all turn into y squareds. This is minus 8y. Don't forget, negative 8 squared is positive 64 times 2 is 128. Minus 8 and then plus 4. So you get 124. And then don't go through all this algebra and get to the end and forget to do plus or minus when you take the square root. There are 2 of them. And that's it. You stop there because it asks you for the y values. If you needed to find the x values for what it's worth, you would plug those back into, you would plug them back into here, one at a time, like we did previously, because they're going to pair up with opposite signs. Okay. This type of question, this is the most algebra we'll do all year, which is why I like it. Yeah. I mean, this makes a really good free response question. By the way, you have a test this Thursday.
Oh, by the way.
Yeah. Uh-huh.
I like it. It's over what?
Everything.
Everything.
Everything. Huh? Yeah, in class. I'm going to do the other thing later. All right. It'll be 2.1 through this section, 2.6. Okay. Particle motion also makes a really good free response. 7. Yeah. Yeah, 2.7. Yeah, we're in 2.7. Sorry. Yes. All right. Yeah. All right. Hey, we're almost done. Let's see if we can push on here. Example 9, and then we can practice our dance after lunch. No, it will be. Yeah, it's 2.7. Sorry. Yeah. 2.1 to 2.7. I misspoke. Yeah.
When you write like this, like that.
Oh, yeah. To get the Y value? Yeah. Okay, so let's come back up here. Remember, if you need the other one, you use this little piece that you plugged into. So remember that x equals negative 8y. Here's what you want to do. Instead of listing these as plus or minus, you might want to list it as y equals the positive version and y equals the negative version. Okay, so here's what we would do then. You can plug them in. So you could say x of, you could treat it like function notation, x of the square root of 3 1/24. That's not multiplication. It's going to equal negative 8 times the square root of 3 1/24. Now, because that notation, we're not used to it, I wouldn't say x of. What I would usually do is say, when x equals positive square root of 3 1/24, colon, and then say x equals. And then, so yeah, that's going to be your x value, negative 8 times that. So the point is going to be negative 8 square root of 3 1/24, comma, the y value you plugged in. I'm sorry, when y equals. That's why, yeah, thank you. When y equals. And then, there we go. Square root of 3 1/24. And then you do the same thing when y equals the negative version, and then you're going to get a positive answer. Right? So the numbers are going to be very, very cumbersome. But the point is you can't just say plus or minus in front of the ordered pairs, because that kind of implies that there's 4 of them, right? And they do pair up. When one's positive, the other one's negative, and vice versa. Okay. All right. Yeah. So any more clarification on that? This is like the biggest. Yeah, it's a big problem. Big. Right. Lots of stuff. So, all right. Example 9 then moves on to expanding our repertoire, okay, of how to take the derivative implicitly. We're becoming masters of the technique and all the algebra involved, okay? We're trying to find the equation of the tangent line to this graph at this point. Okay, equation of the tangent line. We know what that is, right? That's y equals y sub 1 plus m times x minus x sub 1. That's Taylor form. Hey, look, we already have x sub 1, y sub 1. So we already have 2 of the 3 things that we need. This problem's practically working itself, isn't it?
It sure is.
All we really need to complete the task is to find m, which is the slope at that point. Slope at a point, slope at a point. Big D, not Dallas, although they were good yesterday. Derivative, right? Okay. So let's go ahead and take the derivative of this equation. How many y's do we have in here? 2. So we should have 2 dy dx's. Here we go. Chain rule d dx colon 3 blob squared becomes 6 blob to the first. And we just write the blob in there. Times the chain rule, the derivative of the inside. which is the quantity 2x dx dx, which we don't need, plus 2y dy dx that we do need. That takes care of the left side. And now the right side is a product rule. I can say that the 100 is part of the x and think of it as 2 factors instead of 3. So the derivative of 100x with respect to x is just 100. Y goes along for the ride. Plus 100x goes along for the ride times the derivative of y with respect to x. There's the derivative. That's the calculus. Calculus is done, and now there's still a lot of algebra left. Now notice, if you were trying to solve for dy dx first and then plug in the 0.31, you could totally do that, right? In order to combine your dy dx terms, which is why I'm giving you this example, I can't just freely get the terms together yet, can I? The guy on the right is free to move. He's a term on that side. He can go to either side. But this dy dx on the left side, he's trapped. He's got chores to do inside the house, and he can't be freed until he does his chores. How do we spring him loose as a term? You take whatever's out front and you what? You distribute it all the way through. You expand it out. If you expand it out, you're going to have some gnarly terms, aren't you? Right. You could, right? And you could actually be very diligent and take care of each term, solve for dy dx. But we're after just the numeric slope. So here's where the strategy comes in of, hey, let's plug in first and then solve rather than solve then plug in. Okay. So now I'm going to say at the point 3, 1, colon. This becomes 6 times 3 squared is 9, 1 squared is 1, 9 plus 1 is 10. Oh, that's fantastic. So then that's times 2 times 3 is 6, plus 2 times 1 is 2, dy dx. And that equals 100 times y, which is 100 times 1, minus 300 dy dx. And notice what we really have in front is a 60, right? That's a 60. So here's the deal. I still have to do the exact same algebra to get my dy dx's together, but now I'm doing it with a number instead of like this entire 6 quantity x squared plus y squared, right? I have to distribute the 60 all the way through, okay? But it's a lot easier, a lot easier. Let's go ahead and distribute the 60. 60 times 6 is 360. Yeah. 60 times 2 is 120. And the left side looks like it's good to go. We just rewrite it. So now it's like an algebra 1 problem, right? Piece of cake. Now let's just get our dy dx's on the left. You bring the 300 across. What's 300 plus 120? 420 dx. 420. People, whenever that word, people like laugh like that, like in. Did I mess up? What?
Why is it negative 300 on the right?
Negative 300 on the right becomes positive 300 on the left. Oh, I don't know. Did I plug in wrong? It was a 1. I plugged in a 3. I just turned it into a negative. I think I was working towards the marijuana joke subconsciously. And yeah. Thank you. That's a positive. That's right. Let's talk about getting credit, because if this were like an AP exam or one of my exams, you made one little careless mistake, you got derivative credit, you'd lose an algebra here, but then you could recover if you have, well, there's only one thing left really, right? So it would just be one check. But yeah, you want to be diligent all the way through. I made a careless mistake. I'm going to now leave the 300 on the right-hand side because I don't like negative leading terms. So now that switches my whole strategy. You go over there. What's 300 minus 120? 180 dy dx. And then 100, you come over here, 360 minus 100 is 260. Yeah. I said now we're back in algebra 1 and I made a mistake. Now we divide through by 180, and you get 260 over 180. The trailing zeros divide out. There would be no need to simplify, though, right? But I'm going to. So 260 1/80ths is 26/18, and there's still a 2 in there, right? So it becomes 13/9. So wow, all that work. Remember, we had 2 of the 3 things we needed. But that one last thing, whew, it was kind of a booger. So when you're trying to combine your dy dx's, and one of them is trapped inside a parentheses, you got to spring it by distributing. If you divided both sides by 6x squared plus y squared, it would free it up on the left, but now it entraps it in the numerator on the right. So that's why you have to distribute instead of divide. Okay. Anyway, that was the point of this problem. Now we have 13/9. It's almost trivial, right? So the tangent line is, let's give it a name. What do you want to use for the tangent line instead of just boring y? Robert? I'm going to use big R of x or Robert of x. Yeah, that's too many variables. How about Bob of x? Bobbert. No one goes by Bobbert, you know, Robert or Bob, but no Bobbert. Do you?
Yes, well,
The y value is 1. Oh, okay. Plus 13/9 times x minus 3. Okay, so going back to my careless mistake, I would get credit for the derivative, probably 2 checks for the derivative, 2 checks for implicit differentiation instead of 1, right? That's worth it. You get 2 checks. I would have lost the point here because I would have had a different dy dx. Lost that point. But then if I use that incorrect slope correctly in my tangent line equation, I recover. Then I get the tangent line equation check, okay? So never ever give up on a problem. Don't like deliberately make a mistake so you could say, here's where I'm going to push forward, push on in spite of it, right? But never give up. Go all the way to the end. I think they call that sisu. All right. Comments or questions on that one? Implicit differentiation. It's heavy lifting. It's heavy lifting. We didn't even take inventory, but we did it correctly, right? With every derivative task, we've always had a way to keep inventory, right? Like the product rule, 2 factors, 2 terms. Chain rule, 3 layers, 3 factors. Now implicit differentiation, right? However many y's we have, that's how many dy dx's we have. Show you the what? Oh, the tangent line equation. Yeah, yeah. Okay. Yes.
Can we just put like so this or
Yes. No, that's fine. Yeah. That's fine. Yeah. So, or therefore, r of x because you're answering the question. Yeah. Does it hurt to put so the tangent line equation is? I could have even written the tangent line equation is. It's not required. But remember, the goal is not just getting the right answer, but communicating. I'm tripping over a lot of things today. All right. We have time to squeeze in this example before lunch. And you might be asked this, okay? You might be asked to find the second derivative implicitly. Oh, yeah, cool. So let's try it out. Ready, Ethan? About face. Find d squared y over dx squared as a function of x and y if 2x cubed minus 3y squared equals 8. Beautiful, beautiful addition to a free response question. Okay, you've already done all the work with dy dx. Now they're like, boom. All right, notice it says as a function of x and y. That's in bold. Y'all see that? That can be easily like just overlooked as you're reading. Now, to get to the second derivative, which, by the way, that's what this is, right? D squared y over dx squared. It's the same as y double prime. We have to go through the first derivative. Yeah. And it's not solved for y, but we're not going to solve it for y because it would require 2 equations. So let's just take the derivative with respect to x as it sits. I'm going to choose flavors here that are different than green. Let's see. Let's see. No, I'll just, I'll use blue. 3 times 2, that's 6x squared times dx dx, right? We don't need that, but it's good to keep thinking that in your head. And then the next term would be minus 6y to the first times dy dx. We do need that. And then 8 goes to 0. So again, check before you move on. I had 1y. I have 1 dy dx. Looks good. All right, so now we're at a crossroads. Here's the deal. Should I jump in and take the second derivative immediately because I know how to do it implicitly? Or should I solve for dy dx first and then take its derivative? Yeah, if you can always solve and get an explicit equation, it's going to be worth it. I couldn't get an explicit single equation for y, but I can get an explicit single equation for dy dx. Okay, so let's go ahead and solve it. Okay, it'll make life easier. Bring this across and you get 6x squared equals positive 6y dy dx. And then we divide both sides by 6y, and you get 6x squared over 6y, but your 6's divide out, or they divide out from both sides. So there's dy dx. Now you might have already found this, like if this were a true free response, this might be somewhere up above already, and we've been using it to find horizontal tangents when x is 0, vertical tangents when y is 0, so on and so forth. Now let's take the derivative of both sides again with respect to x. So d dx one more time, colon, and this is why it looks offset. d dx, dy dx becomes d squared y, and then dx dx is dx squared. So again, I think I mentioned that when we looked at notation, but that's why the 2 is offset. It's the second derivative of y with respect to x. Okay, and then on this side, we're going to have to use the what rule? Hody high rule, yeah. Hody high minus hody ho over ho ho. My wife made us put up our Christmas tree yesterday in the house. Happy Halloween to us at home because the kids are gone. So that's how I celebrated Halloween at home, watching the Astros win and the Cowboys win. Yeah, tree's up, everybody. Oh, d high is 2x. Hody high minus high. Hello, high. And then d ho is dy dx all over ho ho. All right. Now remember, on a free response, you don't have to simplify. Is this already solved for the second derivative? Yeah. It is, right? So can we walk away here and get full credit? You'll get 1 out of 2 points if you walk away now. And this is where some students make that mistake. They leave points on the floor. Like, I don't need those. I don't need those. You want to take all the points you can get. Don't be like, I'm going to save those for someone else. No, I'm going to leave those there and stick it to the man. Well, you're the man you're sticking it to. Because remember, this is not incorrect. But remember what it said up here in bold? Write it as a function of x and y. And right now, the second derivative is a function of x and y and dy dx. Oh, goodness gracious. If only there were a way to replace dy dx with something that is equivalent to in terms of x and y.
That's difficult. Where will we find
Yeah, OMG, right? Hey, there it is. So this equals, and irresistibly, I can't help but reorder those first terms, right? So 2xy and then x squared times x squared over y, all over y squared. Would there be any incentive at this point to eradicate the complex fraction on a free response? No. 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 Okay. So now you would get full credit because now it's in terms of x and y. So that one little extra step. And notice, to be able to substitute dy dx in there as x and y, we had to solve for it first, right? So that's another reason why if you go on to the second derivative, you want to solve for dy dx before you proceed. You're not going to be able to solve for y, so we have to do it implicitly, but solve for dy dx first. Do you want to see what it looks like if we just took the derivative straight up here? Let's do it. This would be the contrast. Let's just take the derivative of this dude right here. Okay. All right. With respect to x, the derivative of 6x squared is 12x to the first. No one's going to tell me when to take the derivative. I do it when I want to. Minus. Look. Now Now I have a product rule, negative 6y and dy dx. Those are two separate factors. Well, what would be the derivative of negative 6y with respect to x? It would be negative 6 dy dx times dy dx goes along for the ride, right? Plus negative 6y goes along for the ride times the derivative of dy dx, which is the second derivative of y with respect to x. There it is, and that equals 0. So I had to do the product rule. Now notice this is dy dx times dy dx. That's dy dx squared. This one over here is the second derivative. Oh, and by the way, in order to put it in terms of x and y, guess what you need to do anyway to get rid of dy dx? You need to come back and solve it for dy dx. So yucky, yucky, gross, gross. But it is interesting to show. Remember, I told you if you have a product rule and there's a negative there, it's probably easier just to keep the negative like distributed as you go. Like think of that first factor as being a negative 6y. Otherwise, you may forget to distribute it. Little details, right? You got to be very diligent, which is why the worksheet is so fantastic. It's basically an exercise in meticulous diligence, right? And assiduousness. Those are all good words. Persistence, sisu. Okay, and unfortunately, we're at the end. So any comments or questions on implicit? When do y'all want the worksheet due? Wednesday? You want an extra day? Wednesday? It should probably do, yeah, I'll make it due Wednesday. That's fine. That's fine. Now, I'm only going to test you through this, but we are going to move on. Okay? We are going to move on. Maybe I will test you through the other stuff because I think you'll like it. Okay? We're getting, yeah. Okay, I'll only test you through this. How about we say that? Test Thursday, 2.1 to 2.7. Okay? There it is in writing.